Cool. You guys know I love 3D printing, and I could go on and on about how I think it's one of the greatest recent inventions. It's democratizing design and giving more and more people the ability to design the world around them and to solve problems better and faster than ever before. But even I will admit that it's not without faults. One of the bigger problems with 3D printing is the amount of plastic waste it creates. Blah! No one likes that. Some parts require support material, creating a good design requires iteration, even the best printers fail from time to time, and so all of these things are creating bits of plastic that don't have much use. Now there are definitely amazing people working on this problem. I think NASA just sent a machine to the International Space Station called the Refabricator, which actually recycles failed prints that they're making up there in space. It's wild. I actually just got access to a machine myself that's gonna let me produce my own filament, and I'll be sharing that with you guys very soon. But today we're gonna be doing something a little bit different. Quite a while back, in one of my earliest videos on this channel, I already started experimenting with recycling failed prints, melting down plastic into sheets using a toaster oven and trying to repurpose that into something else. For the most part, I just made some sheets of cool, colorful plastic. I tried making some bowls, I made some guitar picks, but there was still a lot of work to be done. Other designers have also taken on the challenge. I know Augustin Flowalistik has his plastic smoothie project where he also made sheets of plastic and then cut it out with a laser cutter. But you know, whether you're gonna buy a filament recycling system or a laser cutter, it's all kind of pricey. Well, today I'm gonna do something similar. Once again, I'm gonna make some plastic sheets and I'll share with you how my process has changed a little bit in the past 2 years. But then the really exciting part is that we're gonna cut it up using an ultrasonic knife. This is the Wondercutter S. It's like an X-Acto knife, except it vibrates 40,000 times per second, which should produce really clean, smooth cuts through our plastic sheets. So the idea today is to take these plastic sheets, cut them up with the ultrasonic knife, and hopefully give these failed prints some new life. I am so excited to try this thing out, but first let me give you a quick update on how I've changed my process in terms of making these flat plastic sheets from recycled prints. For one thing, I started using this little food processor to crush up my prints. It is definitely small, and ideally I would use a strong blender or even an industrial grinder, but I got this for $3 at a thrift shop, and it sure beats crushing up my prints with a sledgehammer like I was doing before. I filled several containers with these crushed up prints, trying to keep separate colors apart so that I could have different formulas to mix together and get creative with later on. I also decided to swap out the conventional oven and instead use this electric griddle to melt my sheets of plastic. And I'm also gonna put this flat pan on top to create the top surface. Though this is Teflon, I decided to use a bit of MR150 mold release just to make sure that the parts come off. Next, I'll dump some plastic on there and try to spread it evenly so that we can create a nice thin sheet. I'll put that pan on top and let it rest for 10-15 minutes. Here it is a few minutes later, and it's not completely melted, but it's stuck together enough that I was able to flip it over to see what that will do. I put the pan on top again and applied some pressure, and then after letting it all cool down, this is what I got. It's a bit dirty and not completely flat, but it's definitely a start. From there, I started experimenting with different patterns and taking advantage of all these different colors and seeing how I could mix them together to create interesting results. I also ended up putting weight on the top pan to help smush down the plastic even more in the form of this heavy steel vise, and that ended up giving me much thinner sheets, which is exactly what I was going for. I've got a lot of failed prints, so I kept doing this with different color combinations, slightly different methods, and as you can see, I got some really cool results. The resulting sheets are pretty flexible, although the plastic is still brittle overall, but I was definitely able to produce some really cool pieces. This was really fun to experiment with, just seeing how the different plastics melt together and what kind of patterns they create. It wasn't long before I had this whole collection of different sheets of plastic to start messing around with. Okay, so now I have a nice big bundle of these plastic sheets at my disposal. So I'm really excited to put these to use. I'm really excited to try out the Wondercutter. Let's open this thing up. As I mentioned, this is an ultrasonic knife. So while it has a blade similar to your average X-Acto knife, this machine will vibrate the blade at 40,000 vibrations per second, essentially sawing through your material at a microscopic level. The blade is connected to this unit, which has a rechargeable battery, although you can also run it plugged right into the wall. It also includes 40 spare blades, some tools, and the plug. Now, as excited as we are, it's always important to first absorb all the information in the instruction manual. Ah yes, safety glasses are important, and you're also gonna wanna wear your safety gloves. All right, let's hold the power button here and turn this on. And then there's a second button on the handle itself. And the blade will only vibrate when you're actually holding that down to prevent any accidents. Let's try this out on this little sheet of styrene that came as a tester. Oh yeah, so immediately trying this out, it's much easier to cut through materials like this than a standard X-Acto knife. It basically melts through like a hot knife through butter. The results of those rapid ultrasound vibrations are very apparent. I can even cut through this styrene using the blade backwards. While it feels like I'm using a hot wire to cut through the plastic, this isn't actually generating heat, it's just the vibrations. Although the friction of those vibrations can generate heat depending on the material you're cutting through. Cutting through cardboard worked quite decently, although you might as well just use a sharp X-Acto knife for that. But the power of this knife really shows when you're cutting through plastics, like this empty spool of thread. There's definitely no way I could cut through the spool like this just using an X-Acto knife. But you can also see that those vibrations are creating enough friction here to start melting the plastic, which isn't ideal. Anyways, let's go ahead and see how it works on our recycled PLA sheets. Oh yeah, we're definitely getting a nice clean cut here. Although, as you can see, we're also still getting a bit of melting from the plastic. The thing is, since this knife cuts through everything, you can't rest the piece on top of a piece of foam or on top of a cutting mat because it'll just cut through everything. So I ended up having to just hold my pieces up while cutting through. It also didn't take long to start building up some melted plastic gunk on the blade, which does seem to affect the cutting a little bit. The easiest way that I discovered to clean off these blades is to just cut through some foam core like this, and that ends up smudging off the plastic. It did take a bit of getting used to, but slowly and surely I started getting a hang of cutting with this Wondercutter. It's really fun to make these organic, wiggly cutouts. Once again, you can see the plastic is melting a bit, so it kind of fuses right back to itself. Although with a bit of wiggling, I was able to break the parts free. The cuts are really smooth, although clearly the melting does cause some messy edges. To clean those up, first I wanted to try just hitting it quickly with my heat gun, although that didn't really work. It ended up just warping the whole part. It could be cool for certain effects, but in this case it's not what I was going for. Still, this is super fun, so I ended up doing the same type of free-form cutting on some of my larger sheets of plastic. In the end, just going around all of these edges with the standard X-Acto knife does a pretty good job of cleaning them up, although it definitely is an act of patience. I also picked up one of these swiveling deburring tools, and that helped out a bit, although it really only works well on inner corners. Outer turns like this can be tricky, and in the end I actually found it easier to just use the X-Acto knife. After cleaning up those edges, I thought these already looked so great that I ended up just putting a bit of foam and double stick tape on the back and sticking it straight on my wall as a little piece of abstract art. The way these plastics melt together alone already results in such cool patterns that you really don't need to do much else to create a pretty spectacular looking piece. Another thing I decided to try out was just using these plastic sheets as a canvas upon which I could work with my 3D pens. So here I'm doing a kind of experimental piece following the curves with my pen, and I ended up creating a very corally looking piece. In this case, I just kept adding to it and pushing it further and further, creating a very strange looking thing, and I'm not exactly sure of how I feel about the end result. It's definitely something interesting, and it's got a good wobble to it too. I already had some screws on the wall, so I just went ahead and hung that up. Fantastic. Wall art. Of course, I still wanted to see if I could make some more functional things using this plastic sheet. So, as a lot of people suggested with my original plastic recycling video, I decided to make a pick guard for one of my guitars. To start out, I just traced the contour of this guitar to kind of start a template of what my piece is gonna look like. I cut that out, laid it on my guitar again, and then did some refinement until I had a template that I liked. Then I taped that to my piece of plastic and cut that out using the Wondercutter. Here's what I came up with. It worked out pretty well for the most part, although I did end up redoing the curve on the top since that was kind of messy. I finished it off with a bit of sanding to really get some nice smooth edges here and make sure all the curves were more smooth as well. And finally, I'll just use double stick tape on the back of this in order to attach it to my guitar. Also in my first video, I got a lot of people suggesting using one of these pick punches to make my guitar picks instead of cutting them out on the bandsaw. So I bought one and tried it out. It definitely works, although the edges aren't completely clean, and this would probably end up working better with a more flexible plastic like ABS. But hey, it plays. Another thing I wanted to try was scanning one of these pieces into my computer so I could design a perfectly shaped inlay. So I printed out this phone case with the negative cut out of the back, and then I just had to take my piece and press fit it into place. In this case, it had a very tight tolerance, so it did take a bit of weaseling to really fit it in, but once it was in there, it created a really nice, smooth inlay. I just added a few dabs of super glue along the back to make sure it sticks into place, and there we go. Finally, I thought I'd revisit another thing I tried in my original recycling video, and that was to slump plastic over a form like this bowl. In the past, I used my kitchen oven, but I didn't want to go ahead putting plastic in there again. So this time I just used a heat gun and tried to melt the plastic over the shape of the bowl. My hopes weren't too high to begin with, but the results were even worse than I expected. As it turns out, the process of melting and hardening and remelting this plastic just makes it get continuously more brittle, so it ends up being really hard to work with. Here's another attempt with a smaller, thicker sheet of plastic, and I was just heating this up for like 20 minutes straight until it finally melted over the form. Even then, the result was really brittle and pretty lumpy, not the most attractive looking result. Maybe this could lead to something more interesting, but for now, it wasn't entirely successful. Another suggestion you guys gave was to put the sheet between two bowls to create the inner and outer form. Still, I got the same result where the plastic just didn't melt consistently enough to create a nice, smooth form. Ah well, that's something to keep working on. Alright, so I did as much experimentation as I could fit in this week, and as it turns out, dealing with recycled plastic can be tricky. It's not quite as reformable as the original stuff. But you know what? We still managed to make some pretty cool stuff with what we have. The plastic alone is so cool with all the colors mixed together that it makes pretty good wall art. And we also did this little inlaid piece for the phone, and we even made the pick guard for my guitar, which is pretty fun. As far as this Wondercutter S ultrasonic knife goes, well, it didn't make super clean cuts like I was hoping, but still, as far as making freeform cuts out of this plastic, it's the easiest tool I've used so far. At least it's really fun to play with. I'm gonna go around the house and start cutting random things. So we made a lot of progress this week, but there's also still a lot that can be done, and I'm really looking forward to hearing from you guys if you have ideas for different tools I could use on the recycled plastic, different uses, just how can we get the most out of this material and not just throw it in the trash. All right, one last thing before we go, I do have some new fan mail, so let's go ahead and take a quick look at that. All right, fan mail. I've got a good idea. Let's use the ultrasonic knife to open up some letters. First, we've got a package from Zachary Snyder, coming from Colorado. There's something in here, so I don't want to cut through anything important. Yeah, this knife is fun. Effective, I don't know, but fun, definitely. Not my best idea. All right, what do we have? It's a photo of Zach, presumably, using his resin printer at their makerspace at Red Rocks College. And let's see, he says he wanted to show some appreciation for my great channel, and what better way to do that with some fan mail. Zach is 17 years old from Colorado, and he's had his 3D printer for 4 years. He got the Anycubic i3 Mega thanks to my review. Still a great printer. He's already got a little bit of a business going on, selling replacement parts for a Bose aviation headset. Specialty parts, not a bad idea. And he's working on a custom printing service too. Awesome, so Zach sent me this really beautiful print of his maker coin. The quality is fantastic on these. And here we've got one of those replacement parts that he's working on. Well, thanks so much for the letter, Zach, and great job on being very entrepreneurial and starting a business with your 3D printers. That's awesome. I love to see that. I might as well just use a regular X-Acto knife for that. Hey, textbooks! So this came from Curtis Barr and Daniel Venerberg, and they're part of Serious Polymer Products. They're fans of the channel, and they're also introducing 2 books that are hoping to get people excited about 3D printers. Building Excitement with 3D Printing, and Printing Polymers, a very scientific look at 3D printing and the science of plastic. This stuff looks a lot like what I found in my college textbook when I had to study plastics. Very cool. And there's also a lot of 3D printing specific information. Cool, thanks for sending that over. I might have to read it on my next long flight or something. All right, we've got 2 more smaller letters. All right, here we have a letter from John in California. He says, thanks for the Hexasphericon and especially for the note. So he bought something from my store. And he has a challenge for me. Print a soccer ball. Maybe not the best use for plastic, but we'll see. And he's curious what printer I have. Well, John, I have a lot of printers. Just go ahead and look through my review videos and you'll get the answer there. Anyways, Sean, thanks for buying one of the Hexasphericons. I'm glad you're enjoying it. All right, this last one comes from Indiana. Devin, my name is Max. I'm 15, a photographer and artist, and I recently got my first 3D pen. It's a cheap Amazon one, but I like it. No issues yet. That's good to hear. Make Anything made me want to get one because I think what you've made with them is so cool. Being chronically ill can be isolating, so I've always turned to your art and YouTube to occupy me. When I found your channel, I immediately was interested. 3D printing, Springos, heck yeah. I'll be graduating high school in December and applying to art school really soon. I wanted to send you something and I made the Make Anything logo with my new pen. It's one of my first projects, but I like it. Sincerely, Max. There's the print he made. Very nice. Thanks for the letter, Max. I'm glad that my channel is entertaining and inspiring to you. And you know what? Great luck going to art school. Sounds like you're taking a similar path that I did in life. So you've got great things ahead of you. Awesome, that fan mail is definitely going up on the wall. If you guys want to send me something, I'll put an address in the description. I don't check my mailbox too often, it's far away, but it's always great to hear from you guys. Anyways, that's it for today, so until next time, I'm Devin, this is Make Anything, and of course, stay inspired.